This is chapter 9 again, the same chapter after finishing our example 1, after finishing all the theorems there from the first part. We come to example number 2 now. Again write chapter 9, name of the chapter is circles, class 10. The page number is 196. Okay, example 2. It is like this: a chord of, we will be using all the theorems to solve this numerical, of a circle is equal to the radius. Full stop. Find the angle subtended by this chord at a point in major segment. You remember what is major segment? Major segment is when we draw any chord on a circle, the bigger part is the major segment, the smaller part is the minor segment. So to do this, a chord of a circle is equal to its radius. Suppose there is a circle, okay, and this will be the radius, okay. Same size of this one you will use in the chord. Okay, again read it. A chord of a circle, chord is this one, okay. Chord of a circle is equal to the radius. Fine. So that this length and this length is, it is a tricky question for that. Now find the angle subtended by this chord. This chord will make at a point where? At a point everywhere is there in major segment, not below this. If this is the chord, this is minor segment, this one is major. So on the major part, find the angle subtended by this chord at a point in the major segment. Major segment anywhere I take here, okay. This will be my angle subtended in the major segment, okay. Suppose I take it A, B as the chord. As usual, this is taken as center, this is C. You have to find this angle. How much is this angle? Find the angle subtended. Remember that nothing is given, not even that how much is the value. Only the tricky thing is circle is equal to the radius. Chord is the chord of the circle is equal to the radius. From there you have to understand what is the angle value. Okay, suppose I join it here. Why I join this two? Because there is a theorem, you remember 9.2, where it says that angle subtended at the center is double of this. So that is why we draw this. Okay, so we join this two. That is the reason. Now it is easy. Now look at here how to do. We know that if I know this angle, this will be known. But how to know this angle? If I know AOB, its value, suppose it is AOB is equal to 100, then ACB will be 50. That we know. But how to find AOB is the first thing you have to do. If I look at AOB, this triangle has something. It has OA and OB, both radius. And one more thing, the chord is also equal to the radius. That means what? Here you write OA is equal to OB equal to AB. Why? This is given. It said that the radius OA, radius OB is equal to the chord AB. Okay. So that means what? So triangle OAB is an equilateral. L-A-T-E-R-A-L, equilateral triangle. Equilateral triangle means what? All the angles will be equal. If all the angles are equal, that means what? In this triangle, all are 60, 60, 60. Okay, all the angles are equal means what? 180 has to be divided into 3 parts. So 1, 2, 3, 180. That means everyone is equal. 8, 60, 60, 60. So angle AOB is equal to 60 degree. Also, we know what we know. We know that the angle subtended by a chord at the center. This chord making a center angle at the center is double the angle subtended by that chord at any point on the remaining part of the circle. Circle or major segment also you can say. Okay. You can write here arc also. But precisely if you don't write, no harm. Just you have to indicate that it is the reason. Now this enables me to write that therefore angle ACB is going to be equal to AOB. That means what? Half of AOB, right? This is what I said here. I said that AOB will be double of ACB. That means ACB will be half of AOB. We already know what is AOB. Very easy. Half into 60 degree. Angle ACB is going to be equal to 30 degree. Okay. You see, this theorem helped me. 9.2, theorem 9.2. It helped me. The theorem was 9.2, yes, that helped me doing this example number 2. Okay, like this every theorem will help you doing one or the other problem. Thank you.